All right, folks, let's take a wild ride into the wacky world of microchip design. I know, you're thinking, how can this be hilarious? Oh, just you wait. First off, imagine a bunch of tiny engineers. No, not actual tiny people. I'm talking about the engineers who work under microscopes to design chips so small you'd need a magnifying glass just to say hello to them. And these engineers, they've got brains the size of, well, a really big brain. Now, these microchips are the brains of all our devices. Your phone, your laptop, even that smart fridge that tells you when you're out of milk. All powered by these minuscule marvels. But how do they come to life? Buckle up, we're diving in. First, let's talk about something called architecture. No, not the kind building fancy mansions. Chip architecture is like the blueprint of a house, but way more complicated and with zero room for a pool. Here, engineers decide how many rooms, or in this case, cores, the chip will have. More cores mean more multitasking. It's like having multiple brains working together. Imagine being able to watch cat videos, play video games, and write an essay all at the same time. Talk about efficiency. Next, we move to the design phase. Think of this stage as a giant game of Tetris, but instead of fitting blocks, engineers are fitting transistors. These tiny switches control the flow of electricity. If they mess it up, well, it's game over for your device. Now, picture a room full of engineers playing Tetris on a microscopic scale. Hilarious, right? Once the design is perfect, it's off to the fab. Short for fabrication, not fabulous, although it kinda is. This is where the silicon wafers come into play. These wafers are sliced thinner than a sheet of paper and coated with magical pixie dust. Okay, it's actually photosensitive chemicals. Through a process called photolithography, patterns are etched onto the wafer. Imagine using a stencil to draw, but instead of crayons, you use lasers, pew pew. After etching, it's time for doping. No, not that kind of doping. This is where the wafer gets bombarded with ions to alter its electrical properties. Think of it as giving the silicon wafer a superpower. Then comes the packaging stage. The chip is cut from the wafer and placed into its protective casing. This is like wrapping a tiny, fragile gift that's going to do some serious heavy lifting. Finally, we enter the testing phase. Here, chips are tested rigorously to make sure they can handle the pressure. Imagine an obstacle course for microchips. If they pass, they get to be a part of your next smartphone. If not, well, let's just say they don't make the cut. So there you have it. The next time you use any electronic device, give a little nod to the tiny engineers and their epic, albeit microscopic journey. Because without them, you'd be living in the dark ages. Or worse, having to talk to people face to face. Thanks for watching, and don't forget to like and subscribe for more fascinating tales from the world of tech. Catch you in the next one.